Alright, we're going to take a look at graphing functions. Up until this point we've been kind of looking at relations and determining if they are functions, looking at domain and range and all that stuff. We've actually practiced graphing equations before. There's just a little bit of a spin on today's graphing. It's a bit of a review, but the equations or functions are in kind of some different forms. So the book will recommend, as well as I will recommend, if you have an equation that's not in a very nice form, for instance, negative x plus 2y equals 6, I would solve for y. That's the first thing I would do. Now remember, we can move things to either side of the equation. So for instance, I could add x to both sides of this equation. We learned this in the solving for a variable category. So we're left with 2y equals, I'm going to put x plus 6, since 6 is positive. Alright? And then the last thing we're going to do is divide by 2 to solve for y. Now the thing is, you can either write this whole thing over 2, that's completely fine, or you can look at it like x divided by 2 and 6 divided by 2. Just make sure every term is divided by 2. So really what this is y equals, you can either write 1/2 x or x divided by 2, whatever you're comfortable with, plus 6 divided by 2, which is 3. So this is our equation, but what they want us to do with this is take the given domain, and we're going to find those points, okay, on the graph to the right. Okay, so for instance, if I plug in -4 for x, what am I going to get for y? Alright, so if I know x is -4, I take half of -4, which is -2, and then I'm going to add 3 to that and get 1. So one point that I can graph is -4, 1. About right there. Okay? And we're going to do that for each point. If x is -2, I put -2 in for x. Half of -2 is -1. -1 plus 3 is 2. So -2 up 2. Alright, and we're just going to continue doing that. So if I put 0 in, then I get half of 0 is 0, plus 3, I get 3. So 0, 3 is the point. And then now you can start to see kind of a trend. We're going over 2, up 1. So I can bet that the next point is going to be right here, which would be 2. If I plug in 2 for x, half of 2 is 1. 1 plus 3 is 4. So 2, 4. There we go. Now I'm not going to connect those dots because we only looked at this specific domain. Okay, we're defining what x can be. All right, so it wouldn't make sense for me to put a point, but like at 1 something right here, because the domain was not. They weren't asking for that point. So we're just going to keep them as dots. This is a non-continuous graph, and we can only have this domain in that graph. So I can't have any lines or connections or anything like that. All right. So moving on, you'll see a little more complex function here. We've dealt with absolute value functions before, and remember, you can think of f of x as just y. So y equals the absolute value of x. We're going to plug in all of these numbers here. So you don't have to put points. Remember, you can look at it as a table if you want to. But if I put -2 in for x, I'm going to get 2 for y, because absolute value always spits out the positive. And then I can graph these points. So -2, 2. And then -1, 1. 0, 0. 1, 1. And there we go. We start to see that V shape that we've talked about before. But again, since we're only talking about these 1, 2, 3, 4, 5 points, that's all we can graph. Okay, so our domain is -2, -1, 0, 1, and 2. I'm going to stop this portion right here, and I have a short portion, 2 more examples for part 2. So I'll split this up into 2 parts, and I'll continue with that on the next part.